Welcome back, everyone. Get ready to dive deep into the world of AI with us today. We're tackling a fascinating paper all about training those massive language models, the kind that power those chatbots that seem to know everything. You know what I'm talking about, the ones that can write you a poem in the style of Shakespeare 1 minute and then debug your code the next.
Yeah, it's pretty mind-blowing stuff. And one of the key techniques behind these incredibly powerful models is something called a mixture of experts, or MOEs for short.
MOEs. I've heard the term, but to be honest, I'm a bit fuzzy on the details.
Well, you can picture MOEs like imagine assembling a dream team of specialists, except these specialists are AIs. Each one has a unique skill set, and they all collaborate to solve really complex problems.
So instead of one AI trying to be a jack of all trades, you have, say, an expert in grammar working alongside an expert in logic, and maybe even one that's a whiz at pulling relevant information from the web.
Precisely. But here's where things get really interesting. Just like managing any team, you need to make sure that no single expert gets overloaded with work. And you also want to make sure each expert gets the chance to truly master their domain. That's where load balancing loss, or LBL, comes in.
LBL.NET, that rings a bell. It's all about making sure the workload is distributed evenly, right? Kind of like a project manager, making sure everyone on the team gets a fair share of tasks.
Exactly. The standard approach to LBL focuses on balancing the workload within these small batches of data called micro batches. So you're making sure that each expert within the MOE gets a similar amount of data to process in each micro batch.
Makes sense. Seems like the most efficient and fair way to go.
You'd think so, right? But that's what makes this research so interesting. The paper we're looking at today is called, get this, Demons in the Detail. And their findings suggest that this microbatch focus might actually be holding these AI teams back.
Okay, now you've got my attention. So what's the problem with focusing on these smaller batches of work?
Well, think about it like this. If you have a diverse data set, like the kind these large language models are trained on, forcing every expert to be a generalist can backfire. It's like asking your star coder to spend half their time writing poetry. I might be able to do it, but it's not the best use of their talent.
Ah, I see. So it's like, instead of trying to make everyone a well-rounded Renaissance person, we should let them focus on what they're truly best at.
Precisely. And that's the core idea behind Global Batch LBL, which is what this paper really digs into. Instead of this micro-level balancing, what if we zoomed out and looked at the entire data set?
So a more holistic approach. Instead of looking at each individual sprint, we're considering the entire marathon.
Exactly. And what the researchers found is that by allowing experts to naturally gravitate towards the data they're best suited for, you actually see significant improvements in how well the overall AI understands language. And that's measured by something called pre-training perplexity.
Perplexity. Remind me what that means again. It's been a while since my AI 101 class.
Perplexity is basically a measure of how well the AI can predict the next word in a sentence.
Hmm.
The lower the perplexity, the better the AI is at understanding the patterns and nuances of language. So it's a really important metric for evaluating these large language models.
Right, so lower perplexity means a smarter AI. And what I'm gathering here is that this isn't just about efficiency, it's actually allowing these AI experts to become true specialists.
That's the key insight here. And it's not just theoretical. The paper reports gains of around 5.1 in perplexity, which might not sound like much, but in the world of language models, it's a significant jump. It's like taking a major leap forward in understanding and fluency.
That's impressive.
Yeah.
But does this translate into real-world improvements, beyond just a number on a benchmark?
Oh, absolutely. They saw improvement on what we call downstream tasks, things like question answering, generating different creative text formats, and even translation. So it's not just that the AI is smarter, it's actually better at doing useful things.
Wow. So we've gone from simply balancing workloads to essentially witnessing these AI systems evolve specialized skills. I'm already blown away. And they actually have data to show this specialization happening in real time.
Oh, yeah. They have a visualization in the paper that really brings it to life. You can actually see the difference in how often experts are selected for certain tasks when you use microbatch versus global batch LBL. With the global batch, you see these clear clusters of expertise emerge.
So we're not just seeing the team as a whole perform better. We're actually seeing the individual members of the team develop their own unique strengths.
That's the beauty of it. And this has huge implications, not just for how we train AI, but potentially for how we think about teamwork in general.
Okay, now I'm really intrigued.
Mm,
But before we get ahead of ourselves, let's dig into those details. How do they actually measure this specialization, and what kind of gains are we talking about?
great question. Let's dive into those specifics.
Okay, so we were talking about how global batch LBL leads to these AI experts becoming specialists. But how did the researchers actually measure this?
Well, they took a look at how frequently each expert was getting selected to handle different types of data. Imagine you're in a hospital and you've got all these specialists, right? You got your cardiologist, you've got your neurologist, you've got your oncologist.
Right.
You would expect each of them to get called in for cases that are related to their specialty, right? You wouldn't want your cardiologist doing brain surgery.
Yeah, you would hope not.
Right. And that's kind of what they observed with these AI experts. With Global Batch LBL, you start to see that same kind of specialization.
Wow.
Certain experts become go-tos for, like, code. Others might be amazing at handling mathematical expressions. Others are really good at, like, literary prose. It's as if the AI is self-organizing in a way, becoming more efficient, more effective in how it structures itself.
That's fascinating. And you mentioned earlier that they saw some performance improvements on those downstream tasks. What kind of gains are we talking about?
They saw gains of around 2 points in benchmark scores,
Okay.
which, depending on the task, can be huge.
Right.
I mean, that means the AI is not only better at understanding language in a broad sense, but it's also better at performing specific actions, like translating languages or summarizing documents with much more accuracy. It's almost as though it's gone from, like, a talented amateur to a real seasoned pro.
It's a pretty big deal then. All that from just changing how we balance the workload. Amazing.
It really highlights the power of specialization, right? Letting those individuals, even artificial ones, really hone in on what they do best. And I think this raises a fascinating question, actually. If we're seeing this kind of self-organization happening in AI, what does that tell us about, optimizing teams of humans?
Ooh, now that's a question I'd love to unpack. But before we go too far down that rabbit hole, let me ask, are there any downsides to this global batch approach? It can't all be perfect, can it?
Well, you're right. There are always trade-offs to think about. One potential hiccup with Global Batch LBL is speed,
Okay.
because you need more communication between all those experts, which can add a bit of overhead.
Right, it's like coordinating a larger team, I imagine. More moving parts mean more communication is needed.
That's it. But, and this is clever, the researchers found a workaround. They added a tiny bit of that original microbatch LBL back in.
Oh, interesting.
And that helped to speed things up without sacrificing much in the way of performance.
So it's like finding that balance between like individual freedom and team cohesion, right?
Mm.
Global Batch LBL lets those experts shine, but you still need everyone on the same page.
Yes, exactly. It's an elegant solution, really. But we should be mindful that this research is still early. The paper mainly focuses on language models during pre-training. That's just the first stage of their learning journey. More research is needed to see how Global Batch LBL performs when you get to fine-tuning. That's where you really tailor the model to a specific task.
Right, right. So like you've got this broad understanding of language, and then in fine-tuning, you're focusing it in on something very specific, like writing medical reports or maybe composing music.
That's a great example. And there's a lot of potential to explore this approach in other areas of AI, like computer vision, where you're dealing with images, or even, multimodality, where you've got text, images, sounds all mixed together.
I feel like we've just scratched the surface here.
Yeah.
We started by talking about this technical concept of load balancing, and now we're having these mind-blowing conversations about the nature of expertise, teamwork, and even what it means to be intelligent.
It really makes you think, doesn't it? And that's what's so exciting about this research. It's not just about making our AI systems a bit better at this or that. It's about questioning our fundamental assumptions about how these systems learn and how we can guide their development.
One thing that keeps coming back to me is that analogy you made earlier about the hospital.
Oh, yeah, with the specialists.
Yeah. Imagine if we structured our organizations more like that. What if we encouraged people to become true experts in their fields and then created systems that made it easy for them to collaborate and share their knowledge?
It's a powerful idea. I mean, think about how much more efficient and innovative we could be if we weren't so focused on making everyone a generalist. What if we really leaned into people's strengths and passions?
It's like Instead of trying to fit everyone into these predefined boxes, we created a more fluid and dynamic system.
Exactly. And what's really interesting about this research is that it suggests that this kind of specialization doesn't have to come at the expense of collaboration.
Right. It's not an either proposition.
Exactly. Just like those AI experts can still work together effectively, even while they're developing their own unique areas of expertise, humans can do the same. We can be both specialists and team players.
And maybe that's the key to unlocking even greater levels of creativity and innovation.
It's certainly a compelling thought, and I think it speaks to a broader trend we're seeing in AI research, which is this move away from monolithic, one-size-fits-all solutions toward more modular and adaptable systems.
It's like we're finally starting to embrace the complexity of intelligence, both natural and artificial.
And that's a really exciting development.
So to our listener out there, if you're feeling inspired to dive deeper into these ideas, I encourage you to check out the paper we discussed today, Demons in the Detail.
And don't stop there. Explore, ask questions, and challenge those assumptions. Who knows, you might just uncover the next big breakthrough in AI or in how we humans collaborate and learn.
Keep that curiosity burning bright.
Until next time, keep diving deep.